Okay, so our next one we're going to go ahead and do example 4, but we'll access it using the toolkit. And again, I'm going to actually cheat and cut and paste from my notebook.
Yeah.
So let's see what we're going to cut and paste. We're going to open the package, and then we're going to open the file, and I have a file there called ex4-jb for Jupyter Book .inp, and we will create an output file called ex4-tk.rpt, and then we're going to actually create 4 commands, command 0 through 3, and in the toolkit we're going to use the set report command 4 times, and we're going to put status equals yes, summary equals yes, nodes equals all, links equals all, and then we'll overwrite the input file and proceed from there. And actually I'll break this command apart once I get it cut and paste so you can see why I did that. Copy that. Paste. Okay, so I've made a few changes. What we're going to do is I simply want to run the program without making any changes, and I'll show you why. I don't think I need to close anything. We're going to open the file, open the hydraulics, run the hydraulics, save the hydraulics files, close the hydraulics, open water quality, run water quality, generate a report, close. And when we get done, we'll look at this report. But look at the input file I'm using. I'm using just the original input file, not the -jb. So watch what happens when we run it. We get an error message. Can't open the input file, that must mean it's not there.
Yes.
JB it will be. There we go. That's what I wanted.
JB is here. That's yeah.
So look at that output.
Yes.
There's not much there, right?
Yeah.
And that's because nothing's turned on.
Yeah. No change.
So we'll keep that same input file. Now we'll activate all these overwrite commands. And we'll save it to a different file name, and then we'll run the new file. Everything else is unchanged, and now that's what it used to look like. Hope I got the video turned. I do. Good. I'll make sure I had the video recorder on. And when we run it again,
so
we've now instructed it to do a full output file.
Yes.
And so now it returns the values that we were anticipating. Okay, so now let's use the tools to do more than just get things. We can get the count of the objects, and then repeatedly change things and rerun it. So we'll look at this part of the code. We'll rerun that live. And let's see what this one's going to do. It's going to get how many nodes, how many links, and how many reservoirs or tanks. And
That's the input,
I'm
yeah.
calling them FGNs,
Yeah.
and it's going to print them to the screen.
Will they ask, first it will ask you?
It's not going to ask me a thing. It's just going to run.
You're recording, yeah.
Then we're going to produce a table of a link ID and diameters. Then we'll produce a table of link ID and head loss per 1,000 meters. And then we're going to change the diameter of link number 4. And then we'll rerun the program and get links and diameters, links and head loss, and we'll see what there is to see. Questions? Fairly straightforward what's going to happen. We're going to essentially get a table very similar to this right here. Excuse me, links. This similar to this one right here. And we're going to have it give us the link IDs and the diameters. And then we'll do a second table, link IDs and the head loss per 1,000 meters. So the first two tables, the second table we produce should be identical. The right column should be the same. Then we're going to change the diameter of one pipe, and we'll see what the head loss changes to. It's going to be somewhat unexpected. Okay, so here we go initially. Diameters, head loss. If we look up here, our head loss was 0.712. What do we get here? Something's different. So be it. I'm not going to worry about it right now. And now when we change the diameter of pipe 4 from 300 millimeter to 100, so we make it 1/3 as big around, which would be 9 times less area, much smaller pipe. The head losses in that pipe and in an adjacent one go way up because there's a much more restricted flow.
Friction increased.
And we can, instead of getting head loss, let's say instead of head loss we want flow. The code for flow is 8. So all we have to do to get flow is we change it from code 10 to code 8. We should probably call this flow. So here's our initial flows, and look at what link 4 used to be, 136, and link 3 was 63. And when we make link 4 real small, it goes down to 16, and link 3 is picking up a lot of the extra flow. And if you look back at the original topology, link 4 is this one right here. So by making that much smaller, link 3 is this one. It has to carry flow that was going down that way because there's not enough room for it. And the hydraulics is not the issue in this case. The fact that we can very easily change values within a computer program is really handy. So if our goal, for instance, was to select pipe sizes to minimize head loss, describe to me in words how you would go about programming that.
Head loss.
Yep.
Like as we said, like we are going to check the changes in the head loss due to the change in the diameter of the pipe.
Yep.
So if you are, we have made the changes in the diameter of one of the pipe. So if you need to see the more head losses in various other pipes, so we can change the diameter of the respective other pipes as well.
Right.
By that mean we can see that how much losses across the net to pleat.
But programmatically, how would we do that? How would you put that into a program?
Oh, like we need to see that how much head loss we are expecting to be okay or okay, not okay.
Right.
If the head loss is reasonably okay for the flow, then by that mean we can control the diameter. And the diameter is like in this particular case, if we are doing manually ourselves, then we need to set the values. But we first of all decide how much head loss we are expecting. By that mean you need to go for the diameter.
I think you're on the right track there, yeah. So what I would do is we have this section where we can get the head loss for every link.
Yeah.
And I would simply take the absolute value of the head loss, sum it up. So now I have the absolute value of the sum of head losses, and then I would semi-automatically have the program change diameters and try to drive that absolute value down. So I'd minimize the total head loss in the system.
Like you mean all of the sum of all.
Yeah, that
it's okay. Yeah, because
that'd be how I would do it.
That will be easy.
And as a program, that wouldn't be terribly difficult to write. You would take this. We actually can try that. See how we are for time. I don't want to. Yeah, we got a little bit of time.
Yeah.
I've got the recorder running. I may regret this on a recording, but let's get our head losses back. Okay, so empty list, head loss, and we need an accumulator.
Are you taking the average value?
No, I'm gonna.
Head loss or just only the sum of all.
Okay, let's see what we're doing right here. So it's taking the absolute value of head loss, so that's without regard to flow direction.
Yeah.
I'm adding them all up, and then I'm going to report back to myself. This 3 decimal points should be enough. I have no idea what the answer is going to be. Let's go ahead and take a look. Okay, so the total head losses reports as a 0, which means I have a mistake.
It is an ideal state. It's not possible.
Okay, set that to 0. Put that in the accumulator. It's not accumulating, so let me see what I've done wrong. Okay, I printed that correctly. Let's move the print statement into.
Yeah.
It's not doing the assignment correctly. It's right here.
So is the elbow not okay?
Let's force some things. Let's float that. This is all, we're now in Python issues. Create empty list. It should produce a non-zero result. Let's see what happens. There we go. So now it's, for whatever reason, it has to complete the building of the list before we can do arithmetic on it. Okay, so now our total head loss is 25 point something units, and I actually don't want to see all those places, so we round it. 3 places should be sufficient. Okay, so there's our 20.15, and now let's just repeat that after we change the diameter. Okay, so now we're going to do a single diameter change and see if that has any measurable effect in total head loss. So we run the program. We start out with a loss of 20.15, and after changing it's still 20.15. So let's see if we can reduce the head loss. We'll make that link a lot bigger.
It doesn't still 20.
Well, I have a mistake somewhere. Anyway, you get the point. That's how you can use it to programmatically help you guide things. And we could, once we get it functioning reliably, we could let the computer design the network for us, because it could go through and systematically change link values. Yeah. Oh, I know. I got to use the right variable. There we go. Going from 20.15 to 10 by changing from a 300 millimeter to a 900 millimeter.
It could reach 12, then it could come.
Now if we
1200,
go back to the original example. So with a 100 millimeter, we had 20 units of head loss. When we made it when we shrunk it, it went up to almost 91. It's 5 times increase in total head losses by making the pipe smaller, which makes sense. Okay, let me stop this video. And based on the time of day, we could either we can take a lunch, come back, and close everything up, and that will conclude this short course.
Yeah.
Do you want to do that?
Sure.
Okay.
Even I had my mind to go 30 minutes ahead, 30 minutes more, to see what we can do.